Welcome to HashLearn Studios. My name is Dheeraj and a very warm welcome to the webinar, guys. You're looking at part of the lecture series JEE and NEET, and we were discussing about biomolecules. And in the last three classes of mine to be precise, we looked at carbohydrates. In yesterday's class, we covered proteins, and today will be the continuation of that class, that is enzymes. So enzymes are also proteinaceous molecules. So we will quickly move into the class, guys. Like I said, we were talking about proteins in yesterday's class. We looked at the structural aspect, the physical and chemical properties of various proteins, polypeptide chains, and we saw some numericals pertaining to that. So that was the yesterday's concept under concern. So this was the CPP question. If you remember, we had given you CPP questions after the session ended. So this was one of the important question which I picked up for you guys. So here, like you know, biomolecules is conceptual, so you'll have a lot of theory based questions. So what are the names of the scientists who had obtained many amino acids from hydrolysis of protein? So it is pretty simple. Whenever it comes to proteins, whenever it comes to biomolecules, guys, it has to be Emil Fischer. So Emil Fischer is a scientist who had derived amino acids starting from proteins. So you know that proteins are made up of a lot of amino acids. I can hydrolyze proteins, I can break them, and I can obtain the individual amino acids. That work was predominantly done by Emil Fischer. So this is the question for you from yesterday's CPP. Moving ahead, in today's class, we would talk about enzymes. What are enzymes? What are some of the basic actions, work of enzymes? And we will also look at a couple of examples for enzymes and what really is going to be the functionality of these enzymes. So this would be the important concept that we would be covering under enzymes for today's class, guys. So let's quickly move ahead. All the questions that you would see would not need too much time, so I would appreciate if you can give us the answers really fast. So moving ahead, the first question with 45 seconds timer. Proteins are hydrolyzed by enzymes into. So I told you that proteins are made up of amino acids. So proteins, if you try to hydrolyze them, what are you going to get? So I'm going to hydrolyze them by enzymes. Do I have a specific enzyme? No, there are a lot of enzymes. Proteins can be broken down using a lot of enzymes, the ones which are present in the stomach, which are present in the small intestine, large intestines. So depending on the area of action, the proteins that can be used also will vary. Therefore, we are asking you, in general, proteins under hydrolysis is going to give which component that is present here? Dicarboxylic acids, hydroxy acids, amino acids, and aromatic acids. Okay, we have Zara, Pallavi and Peru joining us. Welcome to the webinar, guys. A warm good evening as well. So Peru says it is C and Pallavi says it is hydroxy acid. It's a pretty straightforward question, guys. If amino acids is going to make up proteins, so when I break or when I hydrolyze proteins, proteins have to break down to give us amino acids only. So it's option C. Peru gives us the right answer first. So it is pretty straightforward. You know it, polypeptides. Yesterday we saw that one amino acid and another amino acid can join together using a peptide linkage, an amide linkage, and then if that happens with a series of amino acid, it goes on to be called as proteins. So if I break them or if I hydrolyze them, it has to give us back the starting material, which is amino acids. So let's move ahead to the next question. The next question is, the pH value of the solution in which a particular amino acid does not migrate under the influence of an electric field is called. So we are giving you an amino acid. Read the question. We are giving you an amino acid and we are asking you what is that pH. We are not asking for the values because again it depends on the amino acid that we are talking about. So what is that pH value called as, under which the amino acids will not migrate? That is, if you take a solution of amino acid, read the question, maybe then I can give you the detailed idea. So it's called eutectic point, yielding point, effusion and isoelectric point. Which one is it going to be? So Pallavi gives us the answer first. She says it has to be isoelectric point. Yes, guys, it's pretty simple. The technique is called as electrophoresis. You study that in biology as well, I guess. So what happens is, if you take a solution of amino acids and if you include or electric fields into it by placing two electrodes. So if you place a cathode and an anode, and if you introduce electric field into a solution of amino acids, the positive part of the amino acid is going to move towards one electrode and the negative part is going to move towards the other electrode, depends on what is the amino acid under question. You should know that amino acids can be positive, it can be negative, it can be neutral, and it can also be polar. So all of these factors contribute in giving a particular charge to the amino acid. Depending on this charge, it will migrate either to the cathode or it will migrate to the anode. Since I told solution, or this I will acidify the solution or I will make the solution basic at a particular pH. At a particular pH, the charge on the basically charged amino acid will not have charge. If it doesn't have charge, it is not going to migrate. What is this condition called? What is this pH called where the amino acids have no charge? That pH is called as isoelectric point. Pretty straightforward. You have to remember this. The pH at which the amino acid does not migrate either to the anode or to the cathode is called as isoelectric point. Now you have to remember that all amino acids will have its own isoelectric point. Like I said, most of them will be charged. The charge can be due to various factors which I just told you 2 minutes back. Once I increase the pH above isoelectric point you guys have understood now. That is the pH under which the amino acids will not move, that will not migrate in the electric field. If I increase the pH above isoelectric point, the species are going to be negatively charged. If I have to maintain pH well below isoelectric point, the most of the amino acids will be positive. It's very simple. I have to contribute to the answer only by telling you that either H plus can be removed or H plus can be added. So if H plus is added, the amino acid goes on to accumulate a lot of positive positive charges and it becomes a positive amino acid. If the H pluses are removed, it goes on to become negative, which is again decided whether the acid is in the, that is the amino acid is in the acidic medium or basic medium. This helps you in telling us whether H plus is going to get added or H plus is going to get removed. So this is a little background around isoelectric point. This is a straightforward question, but I've added a little more inputs from my side which is going to help you in answering a couple of other questions. So isoelectric point is the answer, guys. Third one, a Zwitter ion. Look at it. It's important. A Zwitter ion is it a positively charged ion without a metal atom in it, a negatively charged ion without metal atom in it, an ion with positive and negative charges at different points on it, or a heavy ion with a small charge on it? What is it going to be? A Zwitter ion. Pretty easy question. Positive without metal, negative without metal, with both positive and negative charge, or a heavy ion with a small charge on it is the option. So think, guys. Clockmaster says 7 more seconds. Give us the answer pretty quick. So Pallavi says it is, Pallavi and Zehra, both of them tell us that it is option C. Yes, guys, it has to be option C. I'll tell you how a Zwitter ion will look like. C is the right answer. Zwitter ion. Peru also joins the league by giving us the right answer. So if you take a basic amino acid, I'll start with glycine molecule that we were talking about yesterday. So take NH2 molecule. To this is attached carbon, and to carbon there are 2 hydrogens attached, and you have a carboxylic acid group attached. We know that carboxylic acid groups are strong acids, so it's going to give away the proton. And who is going to take the proton given by carboxylic acid? The amine group. Why? Because it has a lone pair on nitrogen. Therefore H plus is given and H plus is taken. This molecule goes on to become NH3 plus CH2 C double bond O minus. So if I have both positive and negative charges present on different atoms in one molecule, such species are called as Zwitter ion. Therefore it has to be option C, guys. It's option C. Good. We'll move ahead. The next question under discussion is pepsin enzyme hydrolysis. So here you'll have to remember certain enzymes which are commonly asked in national level competitive exams. So pepsin is one such enzyme. If you have the knowledge of biology, using that also you can answer these questions. So pepsin enzyme hydrolysis, proteins to amino acids, fats to fatty acids, glucose to ethyl alcohol, polysaccharides to monosaccharide. So which one is it going to be? So go ahead, give us the answer, guys. Protein to amino acid, fats to fatty acid, glucose to ethyl alcohol, polysaccharides to monosaccharides. Okay, Pallavi says it is option A. Let's quickly wait for the other two people to give us the answer. So Zara also says it is A. And Peru, pepsin, what is it going to do? Pepsin is definitely going to convert proteins to amino acids, guys. Pepsin is a class of proteolytic enzyme. It's a class of proteolytic enzyme. What are proteolytic? Proteolytic enzymes can also be called as proteases. So what is the work of these? These are protein breaking molecules. These molecules are enzymes, no doubt there. These are protein breaking molecules which are called as enzymes. So proteolytic enzyme, pepsin is a very good example for proteolytic enzyme. That is, it will break down proteins, and we saw it in the first question. When proteins are broken down, obviously it has to break down into their constituent material, which has to be the amino acid. So this is a little about pepsin. It belongs to a class of proteolytic enzymes. Proteolytic enzymes are basically nothing but the enzymes used to break down protein into the respective amino acids. So good. Let's move ahead, guys. Okay, I think now is the time to give you guys the right answer for the previous class contest question and also declare who is the winner. So the question that we gave you yesterday was, which is the simplest biological amino acid? The simplest biological amino acid has to be glycine, guys, because we were talking about glycine a lot yesterday. So glycine is this. It is NH2, CH2 and COOH. This is glycine. People gave us right answers yesterday. People who are participating in the webinar, almost all of them gave us the right answer, Z. And you know the drill. It has to be the fastest one to get picked as the answer, the winner's answer. So it was Peru who gave us the right answer. Peru, good. Peru, I think Peru had won the session before that as well. Congratulations, Peru. You have won yourself another atom session. And you know what's going to happen with that? You can get either a question or a difficult concept solved by our in-house experts. The best part, yes, the best part is it gets done within 20 seconds of posting your question online. So that's what's going to, that's exactly what you're going to get from this atom session. So congratulations once again, Peru. So Pallavi gives us the answer. Pallavi, it is not the fifth question. It is the previous class contest question. Good that you gave me the answer. You gave me the answer yesterday as well. But then Peru had answered it a little faster than you. Now, the next slide that you would be seeing, guys, would be this episode's contest question. You will have 60 seconds time, like we normally say, fastest finger first. Go ahead, give us the answer. The quickest and the right answer is going to be the winner's answer. Yes, the slide with 60 seconds timer. Here we go. Enzymes belong to which class of compounds? W polysaccharides, X polypeptides, Y polynitrogen heterocyclic compounds, and Z hydrocarbons. Enzymes belong to which class of compounds? Polysaccharides, polypeptides, polynitrogen heterocyclic compounds, hydrocarbons. Go for it, guys. W, X, Y, Z. What is it going to be? Okay. So Pallavi says it is X. Pallavi was the first one to give us the answer, followed by Zara and Peru. So X and Y is the answer, guys. We'll declare the winner and the right answer in the next class of mine, which is on Tuesday, guys. So let's get going. We have another question picked up for you. Get going. This is the fifth question for the day. Which of the following enzymes is not useful in the digestion of proteins. Which of the following enzymes is not useful in the digestion of proteins? We have chymotrypsin, pepsin, trypsin and lipase as the options. Which of the following enzymes is not useful in the digestion of proteins? Chymotrypsin, pepsin, trypsin, lipase. What is it going to be? Think. Clockmaster says 9 seconds. Okay. Zara says it is A. Pallavi says it is D. Okay. Thumbs up. Peru says it is D as well. So Peru gives it first, followed by Zara and Pallavi. Let me tell you guys, it has to be option D, lipase. Let me give you a little idea about all of the other options. Chymotrypsin is a digestive enzyme. Chymotrypsin is a digestive enzyme. Trypsin is also a digestive enzyme and pepsin is also a digestive enzyme. So pepsin is present in stomach. That is, pepsin along with HCl is what helps in breaking down the proteins into smaller units, smaller polypeptide fragments, which either gets excreted or it gets assimilated into the body, into the system. So pepsin along with HCl is going to do this work for us in the stomach. And chymotrypsin and trypsin, these are parts of a super digestive enzyme. There are certain enzymes called as super enzymes which will be very efficient. Chymotrypsin and trypsin is that part of super enzymes which has serine series. No, you don't have to worry about serine because serine is again an amino acid. So this these two, that is chymotrypsin and trypsin, predominantly have serine fragments in them, and all of them are going to do the same thing, digestive breakdown of protein as a part of digestion. But the best part is, what is their location of action? Pepsin works in stomach, chymotrypsin and trypsin predominantly work in the large and small intestine. So this is a little details about the other options. I've told you that the three all the three act as digestive enzymes. Then what does the actual answer lipase do? Guys, lipase is simple. Lipase is used for hydrolysis of fat. So lipase hydrolyzes fat. So if you take a lipid, the lipid is broken down into, in the presence of lipase, the lipid is broken down into fatty acid. It breaks down into fatty acid and glycerol. Fatty acid plus glycerol. This is the work of lipid. This is the work of lipase, conversion of lipid into fatty acids plus glycerol. So this is a little theory behind this question, guys. Let's move ahead. The next question is, of the following statement about enzymes, which ones are true? So we are telling you which one is the right answer among these collection of points. First one, enzyme lack in nucleophilic groups. Enzymes are highly specific both in binding chiral substrates and in catalyzing their reactions. Basically, they are talking about specificity of enzymes in second option. Third option, enzymes catalyze chemical reactions by lowering the activation energy. Fourth one is pepsin is a proteolytic enzyme. So which one is it going to be, guys? We are asking for the right options, the right choices. So which one is it going to be? Yes, Zara says it is D, option D, and Pallavi says it is option C. Peru, go ahead. Okay, Peru says it is option C. Option C. Okay, Zara also says it is option C. Yes, guys, it is indeed option C. It is indeed option C. Now, what's really happening is enzymes lack in nucleophilic groups. No. I'll just give you a little background about this. Enzymes have active sites. Enzymes have active sites. These active sites are the main reason as to why enzymes can act as catalysts. So active sites are the essence or the ingredient for catalytical activity, guys. So this active sites contain nucleophilic groups, and these nucleophilic groups will bind to the substrate using strong covalent forces. It will bind to the substrate using strong covalent forces. So what is going to happen? Enzymes have active sites. These active sites contain nucleophilic groups, and these nucleophilic groups act on the substrate by creating strong covalent forces. So what is it going to be? Option simple. It lacks nucleophilic group. No. Enzymes are highly specific both in binding chiral substrate and in catalyzing their reactions. Yes, they are. That's exactly what I told you. And you have enzymes catalyze chemical reactions by lowering the activation energy. That's the basic work of all enzymes, guys. Enzymes, whichever is acting as a catalyst, does so by lowering the activation energy. So enzymes will catalyze by lowering the activation energy. This is also right. Pepsin is a proteolytic enzyme. I think the second or the third question we were talking about pepsin. Yes, it is a proteolytic enzyme. It is a protease, and therefore option 2, 3 and 4 are the right answers. So option C is correct, guys. So good. Most of them gave us the right answer. We will quickly proceed. This is the 8th question. Enzymatic reactions are given in column 1 and the enzymes in column 2. So we have given you molecules, that is maltose to glucose, sucrose to glucose plus fructose, and we are asking you which enzyme is going to act on these. Which enzyme is going to be acting on these is the question. Enzymatic reactions are given in column 1 and enzymes in column 2. Which one is it going to be? Maltose to glucose, sucrose to glucose plus fructose, glucose to ethyl alcohol plus carbon dioxide, starch to maltose, proteins to amino acid. Okay, Pallavi says it is B, Peru says it is B, and Zara also says it is B. Yes, guys, we will check. Maltose to glucose, it has to be given by maltase. So maltase is the enzyme used to convert maltose to glucose. Then how is sucrose going to convert into glucose plus fructose? Sucrose converts itself into glucose plus fructose in the presence of invertase. Glucose to ethyl alcohol, zymase. Starch to maltose, diastase, and protein to amino acid, you guys know it, pepsin. So option A is 3, yes, and option B is 4, yes. Option C is 1, yes, and D is 5, and E is 2. Yes, this is indeed the right answer, guys. Okay, just give me a quick minute here. I'll help you in recapping. Maltose to glucose, a pretty important reaction. Sucrose to fructose plus glucose, another very important reaction. That is the main source of preparation of glucose. And glucose to ethyl alcohol, again a commercially very important reaction. And starch to maltose, yes, starch can be broken down because starch is pretty much not as commercially important as maltose, lactose, glucose and fructose. Therefore it can be broken down into other species, and proteins also can be broken down into amino acids for various functions. So these are some of the most important things. Okay, now I think we've pretty much spoken about a lot of concepts that's pertaining to this, and let me add a couple of important points about enzymes. These were some of the crucial concepts when it comes to enzymes. You just have to revolve around these concepts only. It will help you in solving pretty much all problems that's going to appear at competitive exams level, guys. First thing about enzymes, you have to know how enzymes work. You can get questions based on enzyme activity. If an enzyme is acting as a catalyst, how is it going to attack the substrate? If it is going to attack the substrate, what is actually needed to facilitate the enzyme in attacking the substrate. Point number one. So this can be spoken to you in terms of hand and glove model. It can be spoken to you in terms of lock and key model, and it can be spoken to you in terms of induced fit model. So lock and key, glove and hand and glove model is pretty much same. So if I have a substrate molecule and if I have an enzyme, it has to exactly be complementary. That is, if I have to make an enzyme act on a substrate, it has to have complementary position. Only when it has complementary position, it will have a snug fit, a tight fit, and enzymes will work only like this. So I cannot try to make an enzyme react with a substrate which does not have complementary holding like this. Therefore, we call it as hand and glove, because one glove is specific to either the left hand or the right hand. It won't be common to both. And just like that, lock and key model also, one lock specific for one key, specific for one lock. Therefore, it says that. But induced fit model is pretty interesting. Induced fit model is the active site present in the enzyme. I told you what the active sites are. The active sites are the regions present in the enzyme which is responsible for the catalytical activity. So the active sites, imagine I have a enzyme and this is a substrate. So the enzyme is also like this, the substrate is also like this. So as the enzyme comes closer to the substrate, you will realize that the positions are not complementary. If the positions are not complementary, the enzyme will modify its active site in such a way that it becomes complementary to the substrate, and then it goes and binds to the substrate, creating the catalytical effect. Therefore, the active sites changes its configuration as it comes closer to the substrate. This mechanism can be spoken to you guys in terms of induced fit theory. That is, this theory tells you just one thing, the ones that I just told you. I'll repeat. As the enzyme approaches the substrate, the configuration of the active site changes. Therefore, this enzyme can act as a catalyst for a lot of substrates. But we have very few enzymes like these in the biological systems which can change its configuration and attach to various substrates. And as chemistry students, we don't have to know the enzymes which will change its configuration, that doesn't come under the purview of our study. So this is about theory. Apart from that, you have to know the basic features. There are catalysts which can work only at optimum temperatures and optimum pH. That's one very, very important character of enzymes. Apart from that, you just have to recall whatever we discussed in today's classes. So you have to know amino acids are the key players in building up proteins, and enzymes, all enzymes are proteins. There's a very famous saying, all enzymes are proteins, but not all proteins are enzymes. So amino acids are going to make up the enzyme, and enzymes are not just polypeptide chains. The difference between polypeptide and protein is, in a polypeptide chain, the number of amino acid is less, whereas in proteins, the number of amino acid is really large. So that's the basic difference, point number one. Point number two, after talking about how the amino acids are structurally arranged, you need to know that you need to know some very basic names of amino acids and proteins. So you should know enzymes, that is enzymes which are proteins. You have to know about pepsin, chymotrypsin, trypsin, and what it does. Predominantly, you will be questioned only about digestive enzymes. There are no other enzymes that we have to really be worried about. You can have questions based on saliva, the amylase, or you can expect questions in enzyme based on commercial preparations, just like how ethanol is prepared starting from sucrose, how fermentation occurs, does the enzyme has any role to play there. You can get questions from there. So this will be the only portion from where you can expect questions. And apart from that, since it is catalysis, you can have questions. Enzymes are catalyst, you know that. So since it is catalysis, you can expect questions on activation energy. So is activation energy getting lowered? Is it going to increase? So that aspect of the enzyme part also needs to be looked, so that you can wholesomely cover the entire enzyme aspect, guys. So that's it for enzyme. So we have covered so far carbohydrates and proteins as well as enzymes in today's class. So if you, like I said, I'll repeat, if you just concentrate on this much of enzymes, that should assure the multi-level understanding of pretty much the entire thing needed under theoretical aspect of enzymes, guys. So I hope you have enjoyed today's class. If you have enjoyed today's class, please go ahead and share this video among your friends and help them as well. And people who have subscribed to Passport, it is CPP time. We have some questions picked up for you. So what is it going to be? It is going to be some of the best questions that we have come across, so that it's going to help you in answering It's going to help you in understanding it even better. And if people who have no access to Passport, all that you have to do, guys, is just a click. Passport subscription is just a click away. So once you subscribe to Passport, you'll have immediate access to CPP, and you'll have 24/7 one-on-one doubt solving sessions, practice questions, tests from some of the best-selling books, and also video classes covering the toughest concepts and problems. This is going to be everything. Yes. So that's it for today, guys. Have a good day.